If you want to get the benefits of autophagy without suffering prolonged hunger, then you need to understanding what actually triggers autophagy in the first place. Today, in this video, I will give you complete method to unlock autophagy without the hunger. Let's get started. Imagine your cells as microscopic cities, each one bustling with activity, generating energy, building structures, and constantly dealing with waste. Now imagine that inside every one of those cities, a highly intelligent recycling system exists that can break down damaged parts, repurpose raw materials, and even eliminate dysfunctional components before they cause harm. That system is called autophagy, a term first introduced by the Belgian biochemist Christian de Duve, who later received the Nobel Prize for his work on cellular organelles. Decades after its discovery, the Japanese cell biologist Yoshinori Ohsumi won the Nobel Prize in Medicine for uncovering the genetic mechanisms that control this extraordinary process. And what makes this even more fascinating is that your body activates this powerful repair system when food is scarce. But here is the paradox. Modern life has made food abundant, constant, and hyper-accessible, while our biology still expects cycles of scarcity and abundance. That mismatch may quietly reduce one of the most important longevity mechanisms your body naturally possesses. So today, we are going to explore a compelling question. How can you unlock many of the benefits of autophagy without suffering through intense hunger? To answer that, we must first understand what autophagy truly does at the cellular level. Inside your cells are structures called mitochondria, the energy power plants that convert nutrients into ATP, the currency of biological energy. Over time, mitochondria become damaged by oxidative stress, metabolic byproducts, and environmental toxins. When damaged mitochondria accumulate, they leak reactive oxygen species, which in turn damage proteins, DNA, and membranes. Autophagy steps in like a precision demolition and recycling crew, isolating the defective components inside a membrane structure called the autophagosome, and delivering them to lysosomes for breakdown and reuse. This is not merely cleanup, it is rejuvenation. By removing malfunctioning parts, autophagy restores cellular efficiency, improves metabolic flexibility, and may even reduce the risk of age-related diseases. In fact, autophagy has been linked to neurodegenerative conditions such as Alzheimer's disease and Parkinson's disease, both of which involve the buildup of misfolded proteins. And intriguingly, increased autophagy is observed in some of the longest living organisms studied in longevity research. So why does hunger activate this process so strongly? Because autophagy is tightly regulated by nutrient-sensing pathways that evolved to respond to scarcity. When glucose is abundant, insulin rises, and a molecular pathway called mTOR becomes highly active. mTOR, the mechanistic target of rapamycin, functions like a cellular growth switch, telling the body to build, divide, and store. But when nutrients are low, insulin drops, AMPK becomes activated, and mTOR is suppressed, which sends a completely different message: repair, conserve, recycle. This biological switch explains why fasting is such a powerful trigger for autophagy. However, prolonged fasting is not practical or comfortable for many people, and in some cases it may not even be ideal. The good news is that fasting is not the only way to manipulate these molecular switches. The deeper strategy is to influence insulin, AMPK, and mTOR without necessarily enduring severe hunger. One powerful lever is exercise. When you perform high-intensity interval training, your muscles rapidly deplete glycogen, which increases AMPK activation. That activation mimics part of the cellular energy crisis that fasting would create. Studies show that endurance exercise increases autophagy markers in skeletal muscle, essentially forcing cells to upgrade their internal machinery. Even more interesting, fasted exercise appears to amplify this effect because insulin levels are already low before the workout begins. Another strategy involves carbohydrate control. When carbohydrate intake drops significantly, insulin remains lower throughout the day, and the body transitions into ketosis. In ketosis, the liver produces ketone bodies that can fuel the brain and muscles while reducing reliance on glucose. This metabolic shift resembles the fasted state in important ways, particularly in how it influences nutrient-sensing pathways. Although a ketogenic diet does not replicate a multi-day fast, it can nudge the body toward a more autophagy-friendly environment. Time-restricted eating is another compelling approach. Instead of eating from morning until late at night, you compress your food intake into a 10 or 8-hour window. That simple change can create a daily 14 to 16-hour fasting period without dramatically increasing hunger. During the latter part of that fasting window, glycogen stores fall and insulin remains low, gently encouraging autophagy activation. What makes this strategy sustainable is that it works with your circadian biology rather than against it. Sleep, surprisingly, plays a crucial role as well. During deep sleep, growth hormone increases and insulin sensitivity improves. Poor sleep elevates cortisol and disrupts metabolic regulation, which may blunt autophagy over time. So, paradoxically, someone who fasts but sleeps poorly may undermine some of the very benefits they are trying to achieve. Cold exposure introduces yet another interesting dimension. Short bursts of cold stimulate brown adipose tissue and increase mitochondrial activity. This mild stress can activate AMPK and enhance mitochondrial turnover, which overlaps with autophagy-related pathways. In this way, controlled environmental stress may replicate a small piece of the fasting signal. Certain plant compounds have also drawn scientific interest. Polyphenols found in green tea and coffee appear to influence AMPK activity. Curcumin, derived from turmeric, has demonstrated autophagy-modulating properties in experimental settings. While these compounds are not magic bullets, they can complement lifestyle interventions by subtly shifting molecular signaling. But perhaps the most important concept to understand is balance. mTOR is not the enemy, it is essential for muscle growth, immune function, and tissue repair. The real issue is chronic overactivation, which can occur when we constantly snack, overconsume protein, and rarely experience metabolic rest. Strategic cycling between growth and repair states may be the true longevity sweet spot. This is why protein timing matters. Leucine, an amino acid abundant in animal protein, strongly activates mTOR. Spacing protein into distinct meals rather than continuous grazing allows mTOR to rise and fall naturally. That oscillation may be more physiologically aligned with human evolutionary patterns. So when you combine moderate carbohydrate control, time-restricted eating, intelligent exercise programming, adequate sleep, occasional cold exposure, and mindful protein distribution, you create an environment that repeatedly nudges the body toward repair mode. None of these strategies alone equals a prolonged fast, but together, they can simulate many of the same signaling pathways in a far more sustainable way. And sustainability matters more than intensity. A 3-day fast performed once per year is far less impactful than daily habits that gently reinforce cellular renewal. Autophagy is not a switch you flip once, it is a rhythm you cultivate. So the real question is not, how do I avoid hunger entirely? The better question is, how do I design my lifestyle so that hunger is minimal but metabolic flexibility is maximized? Because metabolic flexibility, the ability to switch between burning glucose and fat, is deeply intertwined with autophagy. And metabolic flexibility is trainable. When your body can comfortably transition between fuel sources, short fasting windows feel easier. When short fasting windows feel easier, you sustain them consistently. And when you sustain them consistently, the cellular repair systems that evolved over millions of years begin to operate closer to their intended rhythm. Ultimately, the goal is not to starve yourself into longevity. The goal is to create intelligent cycles of stress and recovery that tell your cells when to grow and when to clean house. Autophagy is not about deprivation, it is about precision timing. And once you understand the signals that control it, you gain the ability to influence one of the most powerful maintenance systems built into human biology. If you found this exploration compelling, imagine what happens when you apply these principles deliberately, week after week, month after month. Cellular repair compounds. Mitochondria become more efficient. Inflammatory signals decrease. Metabolic resilience improves. And slowly, almost invisibly, the internal age of your cells begin to improve. If you found value in this deep dive, hit that like button and subscribe for more such videos.